All right, well, good afternoon. My name is Greg Fenves. I'm Dean of the Cockrell School of Engineering, and I want to welcome in particular all the Cockrell Engineering students here and students from many other schools and colleges here at the University of Texas. This is an inaugural lecture of what will be eventually a series of really keynote important topics that are facing us as a society that engineering and technology are addressing. And I am very pleased to kick off this lecture series with our newest professor in the School of Engineering, Dr. Bob Metcalfe. And Bob is coming to the University of Texas at Austin after, with an illustrious career behind him and one ahead of him as an innovator. Bob is a graduate of Massachusetts Institute of Technology, MIT, and he's also a life trustee now of MIT. And he got his start inventing Ethernet at Xerox Palo Alto Research Company, and has gone on to a long career and long record of accomplishment and innovation in a variety of technologies. He has lately been a very successful venture capitalist at Polaris Ventures in Boston. And as I got to know Bob over the past 6 or 7 months, he was looking for the next stage in his career. And we came to an incredible meeting of minds of what his goals are and what we are working on and achieving at the University of Texas, especially in the School of Engineering, but in combination with McCombs Business School, where innovation and entrepreneurship are really keystones of what I see the future for engineering and technology. And I think this is going to be such an important part of our education and what we do here at the university that I really wanted to get Bob Metcalfe here, and I'm very glad that he is here. And as you'll see, we've given him a very unique title, Professor of Innovation. And he's going to be leading our innovation activities at the University of Texas. Bob is an incredibly smart, funny, creative, to use the cliche, out-of-the-box thinker. I think you're going to enjoy what he has to say today and going to enjoy getting to know him. He's starting to think about the course he's going to teach in the fall of 2011. I think it'll be a very exciting development here at UT. And if you want to follow Bob regularly, just sign up on Twitter. And you can listen to Bob and many of his very insightful observations, analyses, and comments. So today he's going to be talking about one of the most important problems facing us as a society, one of energy, and taking ideas that he's learned through information technology and the development and growth of the internet and information technology, and what does that mean for us in solving this incredibly challenging problem of energy. So without me taking up any more time, let's give a warm welcome to the University of Texas for Dr. Bob Metcalfe.
I see that I have thoroughly overdressed everybody but my boss. So we're here to talk about ideas relating to solving energy, and I use that phrase solving energy, which implies that energy is a problem. And it usually only need one good reason to do something. In the case of energy, we have 3 good reasons. We need it to be cheap so that our economy can keep growing. We need it to not come from dangerous parts of the world full of people who want to kill us. And 3 is energy more and more is disturbing our environment. And we want to be sure, therefore, that by solving energy, I mean cheap and clean energy. And energy is a big topic, and I know it's been addressed before, and it's about to be addressed again. The UT Energy Forum will be on February 3rd and 4th, right over here at the AT&T Center, so not so far away. And I urge you to go there. I've already registered. And it's at www.utforum.com. Is that right, Josh? utenergyforum.com. I'm glad I checked. So please go there for further information. That's February 3rd and 4th. It's always great to start a talk. Hello. So this PowerPoint, I'm going to show you some PowerPoints. It's usually people who are young who disparage PowerPoint. People who realize what it was like before PowerPoint. I was on the board of the company that developed PowerPoint, and we sold it to Microsoft in 1987 for $14 million. And then for 20 years, I didn't use it. I used 3x5 cards, handwritten 3x5 cards for 20 years, except for the big important talks, then I used 5x7 cards. So this is actually my first PowerPoint presentation, and I was provoked to do this by seeing that you could win a Nobel Prize with it, as Al Gore did. I got into energy thanks to MIT's then new president, Susan Hockfield, in 2006, and she decided after a short time at MIT that energy was the next big problem and that MIT should solve the problem. And being a joiner and a team player, I immediately took up energy. Despite the fact that I'm an internet tycoon, I decided to do energy. And I'm not the only internet tycoon who's doing energy. There's thank goodness, a large number of people who practiced on the internet are now turning to energy to help solve it in the coming decades. So what does it mean for a venture capitalist to work on energy? And what that means is to invest in companies. So this is a pretty old list of the energy-related companies that my venture capital firm, Polaris, subsequently got involved in. And were I still a venture capitalist, I would spend the rest of this hour bragging about all of these companies we've invested in, but I'm not going to do that. I'm just going to show you that the way I became a member of the energy team was to begin making investments in promising energy companies. But still, I'm not an engineering person. I'm not an energy person. I never really studied thermodynamics at all. And I was an internet guy. So in 1974, I had already been working on the internet for 5 years. This is what the internet looked like. You're going to see this later. That's what the internet looked like in 1974. And I just hasten to add, you see those big black dots? Those are not cities or even buildings. Those are computers. So in 1974, the computers were as big as this room. There were no personal computers. So we began building the internet to network these big computers. Another annoying thing about this diagram is I noticed that Texas is not on the internet in 1974. I thought briefly maybe Kirtland was in Texas, but it's in New Mexico. It's an Air Force base in New Mexico. What was Texas doing in 1974? I don't know. Anyway, what I was doing was being an internet guy, not an energy guy. So I looked for ways to contribute and noticed that other people in the past had made an analogy between energy and information. Claude Shannon, in doing his information theory, used the word entropy, which came out of the work in thermodynamics by Carnot. So I saw here a promise that if I could somehow analogize information into energy, maybe I could make a contribution in that way. So I began this project. Now, the internet did not go away when the internet bubble burst on March 10th, 2000. It's still here, as you probably know. And one thing I noticed about the internet is that we were able to use the internet to build the internet, kind of a virtuous cycle. Perhaps we can use the internet to solve energy. Well, in lots of ways. We can use the internet as a substitute for transportation and save energy. We can use the internet's innovation infrastructure, all the innovation machinery that was used to develop the internet over so many years can be now turned, as tension can be turned in by degrees over to energy. There's the collective intelligence. We didn't have the internet as a way of collecting intelligence when we were building the internet, but we have it now. So in solving energy, we can use the internet as a way of combining all the 6 billion brains in the world to solve this problem. So I started this I call it an applied history project, which I call Internet, which is to sort of go through the history of the internet, which, as you'll see, I claim is up to 65 years old, and go through those 65 years looking for lessons and applying them to energy. Just see if that analogy works, see if there's some transferable learning. So applied history. Have you all heard the expression, those who do not study history are doomed to repeat it? Have you all heard that? That is exactly what he said. I found out who said it, George Santayana, and he said something else about the past. But what he said about history is that history is a pack of lies about events that never happened, told by people who weren't there. And I guess the only thing I can say about this particular history project that I'm doing is that I was there. The rest you can be suspicious about. So while typing in Santayana, I came up with this hit, which also bears on the history problem, which is, of course, we have to change our evil ways. So my wife's a history professor, and she said if you're going to do history, you need to have an era. So when was the internet era? Looking at this room, I'm sure many of you believe the internet started with the founding of Facebook in 2004. Or it could go back to the Al Gore bill of 1991, which ironically was signed by George Bush. But somehow that doesn't seem to be the beginning of the internet. You can go back, say, to 1973, one of my favorite years, when the cell phone and TCP/IP, the current protocols of the internet, and Ethernet, my baby, were all invented in 1973. Or you can jump all the way back to 1946, which is roughly approximately when the transistor was invented. And you could argue the transistor had a lot to do with the growth and proliferation of the internet and the things that it interconnects. The other thing I like about 1946 is that in addition to the transistor, mobile communications, and I were all born in 1946. So that's where I get the 65 years from. So the internet has 65 years of history, which I claim puts me at my midlife crisis. So what is a concept? So we could argue about when the internet era began, but I think we can agree that it took decades, maybe not 6 decades, maybe only 3 or 4. But the internet was not a 3-year engineering project like the Manhattan Project. And it was not a 10-year engineering project like the Apollo project. The internet took decades, and if the internet is any guide, energy is going to take decades, and that's a different mindset. We're not going to solve energy projects. We have decades. We will be forced to spend decades solving energy, which means, for example, there is time for science. Another consequence of looking at energy as a multi-decade thing is that we have to be careful of hardening of the categories. That is, some of our early dichotomies and trichotomies and taxonomies and phraseologies turn out to be wrong. And when they're wrong, they can slow us down and they send us off in wrong directions. And here's some great examples. When the internet started, the telephone network and the stuff that you connected to the telephone network were all made by the telephone company. And starting in about 1968, someone said, well, that doesn't seem reasonable. Why don't we allow you to connect anything you want to the telephone network, not just to have it all made by AT&T. And so that led to the connection of things like answering machines and ultimately modems. You weren't allowed to put modems on the internet unless they were made by AT&T. And it made the internet possible by allowing you to connect things that were not made by the Bell system. Computers and communications used to be 2 things. Computers were done by the IBM company, and they were regulated by the Antitrust Division of the Department of Justice. And communication was done by AT&T, and they were regulated by the FCC. The FCC actually held hearings in Washington to draw a line between computing and communication so they could regulate the right thing. And that line was immediately erased by the arrival of the internet, because now computers communicate, computers are the communicating infrastructure, they're inextricably intertwined. And voice, video, and data is a more enduring trichotomy that has slowed us down quite a bit over the last decades. On the left, you see a telephone. That's a telephone even before my time. In those days, voice was telephone. In the top middle, you see a television. By the way, those dots on the screen are snow, what we used to call snow. I don't think you've seen snow recently. And by the way, this is HD snow. I stretched the TV out. And then on the right, you have what used to be data communication. That was the original terminal for the internet, an ASR33 teletype. That was I/O for the internet. Well, today, voice is more than telephone. Video is more than television, and data is more than the ASR33 teletype, and all of them are converged, say in this middle bottom depiction of voice, video, and data on a desktop system. But for years, voice people and video people and data people went to different conferences, and they didn't like each other, and they had separate industries, and it really slowed things down. So let's bring this back to energy. So how many of you really like the idea of corn ethanol? You would raise your hand if you think corn ethanol is a really great idea. I've raised this question 41 times, and I've never gotten anyone to raise their hand. But corn ethanol is the law of the land. The Congress of the United States has made this important. And I thought that since this was not one of the coasts, that perhaps there would be someone here in favor of corn ethanol. Do they grow corn in Texas? I don't know. They do in Iowa, so I have to ask this question in Iowa. But a conspiracy of Iowa farmers and food processing companies and people called Greens went to Washington and got the wrong feedstock and the wrong fuel, made the law of the land. And this is an example, I claim, of a categorical mistake, because they believed that you could, if you'll excuse the expression, screw around with corn as a fuel and set prices and subsidies and so on, without interfering with corn as feed or food. And turned out not to be true. And then suddenly, so what are we taking all this valuable food and selling it for fuel and automobiles? This is an early example of a categorical mistake. Feed and food and fuel cannot be separately managed. Let me stop for just a second and see if anyone has a question. Does anyone have a question yet? Someone like to hurl an accusation? I'm going to wait till someone raises their hand and asks a question. I meant to do this earlier, but I forgot. Come on. The T's? Thank you. So in that first picture, I won't go back to it, but in that first picture of the internet, there were some that were black dots and there were some with T's. Those were nodes on the internet where you could dial in with a modem, a dumb terminal, and gain access to the internet. Thank you. If anyone has a question at any time, would you please ask it? And I'm going to try to take questions steadily and at the end, and end promptly at 5 o'clock, although that clock's an hour fast. I hope. Am I 20 minutes over, or that clock an hour fast? So I mentioned that corn ethanol was enacted through an odd combination of Iowa farmers and Greens. And what that was an enthusiasm to go to develop political will and public awareness and go to Washington and do something about the energy problem. And what you see there, I think, is evidence that energy is a movement with true believers. Well, and I'm used to movements because the internet has, like the movement of this slide. The internet was in many stages a movement, many movements. Ethernet, my baby, was a movement. This is an early Ethernet picture. You'll notice the yellow cable. So we had a color. The Ethernet movement, we had yellow cables in all the ceilings in its early days. Well, movements have gods and dogma, clergy and slogans. Like Vint Cerf, one of the fathers of the internet, goes around saying, "I pee on everything." Internet protocol on everything. That was his cute little, his sense of humor is a little warped, but he did invent the internet. Another thing about these movements is what I call inquisitorial religiosity. So for example, during the internet bubble, if you were foolish enough to say, pets.com really sounds like a bad idea, somebody would turn to you, one of those smart-ass Silicon Valley people, and look at you with that sneer and they'd say, "You just don't get it, do you?" And it turns out the people who questioned pets.com did get it, and they were just being shouted down with this inquisitorial religiosity. Well, energy is a movement too. It has all of these features and various instances of it, and including inquisitorial religiosity. And energy has a color. I have discovered through careful research that the energy movement has a color. Would anyone like to guess what the color of energy is?
Green.
Green, that's right. So this energy movement has a color. So Tom Friedman of green, and Tom Friedman of the New York Times questioned a couple of years ago, he questioned this choice of this color. This is a New York Times guy saying, why did we choose green? Because green has a lot of baggage. So here are people on the left who are greens. And what do those people believe? Well, they're environmentalists, and that's admirable. But those people, those greens, they tend to be anti-trade, anti-capitalism, anti-American, anti-technology, anti-nuclear, as the sign indicates. Also anti-hydro, anti-tidal, anti-wind, anti-solar in some cases. So what's true about the greens, I think, I have observed in this notion of a movement, is that they're against almost every tool we might use to solve energy. It is not a good choice of color. So what have I done? I've launched a study to find a new color for energy. How about black? So oil is black, and coal is black, and silicon is black, and carbon is black. Who's going to correct me? Silicon is not actually black. Silicon is gray and mirror-colored. And anyway, black isn't a color. It's depressing. So how about white? You know, if the Earth were just a little bit whiter, if its albedo were just a little bit higher, a lot more sunlight would go back into space, and we wouldn't have a global warming problem. So maybe white is a good choice. Of course, you can overdo white. And several scientists believe that at several times in the history of Earth, it's become too white. It became a great 50 degrees below zero snowball. So maybe you could have too much of a thing. And of course, white is not a color. So I did some scientific research and looked at the absorption spectrum of plants, chlorophyll, photosynthesis. And what do you notice about this chart? There's absorption in the blue and the red, but even plants don't like green. So this picture by NASA gives us a hint as what a better color would be for energy, and that would, of course, be blue. And then you think of the oceans. I learned to fly that submarine, and the guy who taught me to fly it pointed out that Earth has been misnamed. It shouldn't be called Earth, because Earth is mostly not Earth. It's mostly ocean. He claims 99% of the living space on Earth is in the oceans. 71% of the surface is ocean. The average depth of the ocean is 12,000 feet. The ocean is full of temperature differentials, and it's full of waves, and it's full of minerals, and it affects the climate greatly. If we're going to solve energy, we're sure that a lot of things that are blue are going to play a role. Now, at every university that I visit, and I've visited a bunch, I've noticed that they all have a brand new Department of Energy and the Environment. Energy and the Environment. They slur it, actually. Energy and the Environment. And the implication is, and this goes back to that categorization thing, that energy and the environment are somehow inextricably linked. Like they're almost the same thing. And of course, they arrive at that conclusion by noticing the CO2 problem that we have, which seems to be the principal linkage between energy and the environment. But I'd like to point out that if global warming, excuse me for this, what I'm going to show you later is really cool, and it's worth all this hassle here. If we solve global warming, we would still have an energy problem. And if we solved energy, we would still have a global warming problem. Energy and the environment are not the same thing. They do intersect at places, but they are not the same thing. And I'm trying to solve energy. I'm going to focus on, I think we should focus, some of us anyway, should focus on providing the world with cheap and clean energy. So let the environment have green. Let's take blue for energy. Speaking of colors, here's black again. Have you seen this picture, or actually some other pictures before? Familiar? Earth at night. The person showing you this picture usually, especially if you're American, they want you to feel bad. They're showing you this picture and they say, look at this, look at that. And this is sort of a pro-conservation slide usually. So I go back to the internet. In the early days of the internet, we had a thing called the information explosion, and we had 100 years of accumulated copper provided by the Bell system. And we worried that the information explosion was going to overrun the copper plant of AT&T. So our first impulse was to conserve, to use less bandwidth by, say, compressing the bits or using a shared transmission media, using packets, various forms of compression. So then we built the internet. I want to ask you a question. Now that we built the internet, do you think we use less bandwidth than we did before we started? Like, do we use half now? How about we use the same amount? We use double? Do we use double the bandwidth we did? How about we use 1,000,000 times more bandwidth than we did before we built the internet? So if the internet is any guide, when we're done solving energy, providing the world with abundant, cheap, and clean energy, we're going to be using more energy, not less. So this is a mindset thing. In many quarters, the mindset is we're going to use less and less energy until the energy problem is solved. I don't think that's the way it's going to go. Thanks to the internet, we now have a squanderable abundance of bandwidth, which we throw away frivolously. For example, I'm looking at all the personal computers that are currently sitting in your offices, computing their little hearts out on nothing while you sit here, wasted, and communicating over the network and so on. When we solve energy, we're going to have, I predict, if the internet is any guide, a squanderable abundance of energy, and I'll return to that point later.
Professor Metcalfe?
Yes.
To get all that bandwidth, we have Moore's law and the transistor, the fundamental device that allows more and more and faster and faster. What's the equivalent in energy, or is that yet to be discovered?
I think it's on the verge of being discovered, and I'll return to that very point in a few slides. When I get to the slide about Sax's law, you'll see a preliminary answer to that question. But I'm going to argue we need laws like Moore's law. In fact, we need Gordon to be working on them. Now, in the previous slide, I seemed to argue against conservation and efficiency. I didn't mean to argue against conservation and efficiency. I'm just pointing out that when we're done conserving and being efficient, we're still going to end up using more energy. It's almost tautological. This is my car. Actually, I have two cars. This is my small car. By the way, SMATCA is how you pronounce smart car in Massachusetts. and that's my license plate. And the woman driving the car is not my wife. My wife is better looking than that, as you'll see when she arrives in September. So I traded in a 12-cylinder Mercedes, which I got the feeling bad about, for a 3-cylinder Mercedes. So I'm not against conservation and efficiency. I'm just telling you the consequence of making energy cheap and clean is we're going to use a lot more of it. Yes?
You were talking about the bandwidth that we're not using, but I would compete about that we have capacity and there is something that we use. And regarding what we have with the internet, there is like an enormous capacity, but we are using that as much as we need. So like consumption is based on need, but capacity is like foreseeing what we should be. And I'm confused because you were saying like we have a lot of bandwidth. Yeah, like that's capacity.
Yeah, but even the part we use is wasted. Well, every time you type a search term into Google, you get a lot of stuff back that you never use. It must be wasted, right? But we don't mind that. I'm not complaining about all those extra hits that you get on Google. Let me return to my digression. Thanks for your comment. Any other comments at this time? I'm halfway done now. Better hurry up. I forgot to tell you, I have 65 slides. 65 is a magic number for me. I don't know what it is. So a slight digression on that automobile. The internet and energy and automobiles are going to be transformed. And I've just gotten glimpses of this recently, captured by these two terms. Mobility on demand, that's sort of like Zipcar. And robo-transport, that's like cars that drive themselves. So I guess I'm getting to feel now that in my lifetime, which is at least another 65 years, since I own a red convertible, that's my midlife crisis car. That means I will live another 65 years. But in that time, cars will no longer use internal combustion engines. They'll all be electric motors. We won't drive them. No more DMV. I'm trying to get my Texas driver's license. I'm visiting all the DMV departments one by one. No more DMVs because we won't be driving cars anymore, and we won't even be owning them. There'll be an app for that. A bit of a digression. Now, in the meantime, while we're solving energy,
Good morning. Good afternoon.
it must be Chris. Is that you, Chris?
Good
Here, let
afternoon,
me,
Dr. Metcalfe. How are you doing?
Is that you, Chris?
It is. Good afternoon, Dr. Metcalfe.
How are you?
I'm doing great.
Well, let me make
And the audience that is virtually attending with us here, more than 30 people around the globe, are sending their bits directly to your lecture.
So
Just spin around and have a look.
I thought it would be cool to show you, well, this point I'm making on the slide is, in the meantime, while we're developing energy with lower carbon content, in the meantime, we can conserve energy by transporting our bits, not our atoms. And what you have, what you're seeing, is that this talk is being given to people who are not only in this room. These are folks from around the U.S. who are attending, I think it's, oh no, actually international audience attending today. And let's see if maybe I can get a question from somebody in that audience there.
So I was actually planted with a question. I know that there's a lot of technologists in our audience here, and they're actually asking about the ZigBee standard, the 802.15 standard, and wanted to get your opinion on when it's really going to take off from a home energy management point of view.
So after we networked personal computers, so we first networked mainframes and then mini computers and then personal computers, and now we're networking cell phones. And the next step is to network embedded microcontrollers. And there are about 10 billion microcontrollers shipped every year. So we need networking standards for embedded microcontrollers, and there'll be a bunch of standards. And one of them is the one that was just touched on by this question, ZigBee, which is based on a wireless IEEE 802.15.4 radios and so on. So the ZigBee standard is one of several standards for connecting embedded microcontrollers, which are used in energy management, I might add. I hasten to add I'm chairman of a company that sells ZigBee-compatible products, so you should disregard everything I've just said. And I question the premise. I don't know who asked that question. I want to see your avatar.
I'll get the person to raise their hand and see if they're in. Oh, let me see. I can actually look around. They're not there.
In any case, this company is now profitable, so the ZigBee standard has started taking off already. So you see the growth of the ZigBee standard for networking embedded microcontrollers in energy management, thermostats, lighting, switches, and so on. So networking devices in this room using the ZigBee standard. So it has already, ZigBee has already taken off. We're trying to do, those involved in the standardization process are now evolving the standard and making it more internet compatible or harmonious, and that's going on now too. But I think the ZigBee standard is taking off. So thanks for your question. I'm now going to watch this. I'm now going to turn back to my presentation. And then I'm going to zero in on it and continue where we left off. Now you see why the slide was jiggling earlier. Does anyone have a question? This system, which we're currently using, is a new product from Avaya Corporation. What's the name of this room? Avaya Auditorium. This is the Avaya. And the name of
go ahead, sorry.
And the name of the product, Chris is just dying to blurt out the name of the product, but it's called Viaweb.alive, and it's a immersive, collaborative system. And one of the advantages is that you can transport your bits, not your atoms. You can go to a meeting. There's this building off in cyberspace that you can go visit and see slide presentations and meet with people. And so I've been experimenting with it recently just to see how much fun it is. And so thank you all if you have any questions as we go along, be sure to chime in. That's what clapping sounds like in